and technical solution to real-life problems. Students enthusiastically exhibit their project in front of experts. Such platforms boost their confidence. Front of department is strong industry institute interaction, Center of Excellence by Dr. Fixit in the department. Also, department has introduced new elective retrofitting and rehabilitation of concrete structures at SPPU. Benefits of industry institute interaction to the students are sessions by industry expert, training programs, workshops, seminars. Civil engineering cannot be learned in four walls of classroom. Hence, the department provides internship programs to students and ensures that every student do it effectively. Some of internship platforms are Pune Metro, BAI, L&T, Shukya Constructions. During this COVID pandemic, department has provided online internship to the students, placement in core companies and software companies as per students' interest. Learning by involvement is the best technical knowledge. Teamwork and communication, presentation skills, model exhibition. To keep the pace with advanced technology, software training are conducted regularly. Site visit to construction site, airports, water treatment plants, dams are conducted regularly. The department has established international student chapter with ASCE, Institute of Engineers India, CESA, Civil Engineering Student Association, Srishti, an Environmental and Social Awareness Club, Antalam, a cultural club, students also participate in NSS activity. Students and faculty made us proud by winning awards at international and national levels. Our alumni are successfully working in PWD, Central Railway, PCMC, Water Resource Department, MS from reputed foreign university, MTech from IIT, NIT, and also successful in private sectors. Civil Engineering, Dr. D.Y. Patil Institute of Technology, Pimpri, a step towards excellence. PhD in Digital Cyber and SPPE. The department is The department has state-of-art infrastructure and well-equipped laboratories like testing of material laboratory with universal testing machine, surveying laboratory, concrete technology laboratory, fluid mechanics laboratory, transportation engineering laboratory, environmental engineering laboratory, engineering geology laboratory, projects in the field of structural engineering, water resources, environmental engineering, concrete technology, transportation engineering. Projects are industry sponsored based on societal needs and technical solution to real life problems. Students enthusiastically exhibit their project in front of experts. Such platforms boost their confidence. Front of department is strong industry institute interaction, Center of Excellence by Dr. Fixit in the department. Also, department has introduced new elective retrofitting and rehabilitation of concrete structures at SPPE. Benefits of industry institute interaction to the students are sessions by industry expert, training programs, workshops, seminars. Civil engineering cannot be learned in four walls of classroom. Hence, the department provides internship programs to students and ensures that every student do it effectively. Some of internship platforms are Pune Metro, BAI, L&T, Shivke Constructions. During this COVID pandemic, department has provided.
Good afternoon, all. I welcome you all the participants and today's guest on the third session of the second day of the SATAL FDP on a recent development in construction technology addressing infrastructure and coastal engineering, organized by Department of Civil Engineering, Dr. D.Y. Patil Institute of Technology, Pimpri, Pune. Welcome you, sir.
Hello, good afternoon. Thank you very much for inviting me.
Yes, sir. Sir, we'll proceed with the session. So I request Kshitija Tikhe ma'am to please introduce our resource person.
Thank you, ma'am.
Over to you, Kshitija ma'am.
Thank you, ma'am. Take this opportunity to formally introduce our today's resource person, Dr. MC Dev, sir. Dr. Dev sir is a professor in the Department of Civil Engineering at IIT Bombay. He has completed his BTech in Civil Engineering from College of Engineering, Pune in the year 1975, Masters uh, from IIT Bombay in the year 1979, and PhD in the year 1984. He has a vast experience in teaching and industry as well. He has been associated with various institutions in India as well as and abroad throughout his service. He was a director at VJTI Mumbai during the year 2011-12. In the same institute, he was head of civil engineering department from year 2005 to 2008. He has done his postdoctoral in the year 1985 to 89 at Liverpool University, UK. His research areas include coastal and ocean engineering, hydrology, hydraulics, climate change, impact assessment, application of artificial intelligence, and advanced statistical methods. He has been felicitated with many awards and honorary work like Lifetime Achievement Award 2019 of Indian Society for Hydraulics, Professor H. Mathur Award for Excellence in Applied Research in the year 2009. IIT Research Award for Best Paper in the year 2006. Jalavigyan Puraskar 1998 was given by Indian Society for Hydraulics. He got a special recognition for distinguished and meritorious service to ASC as an outstanding associate editor. He has received Excellence in Teaching Award twice in the year 2016 and 2018, and many more. He was an institute chair professor in the year 2014 to 2020. He was the most cited author in civil engineering from India. He has served as a president of Indian Society for Hydraulics in the year 2020, chairman of editorial board, ISH Journal of Hydraulics Engineering, Trailer and Francis, UK, and chairman of review committee for CWPRS Pune. He has been a member of various institutions and committees. Few of them are member of editorial board, Applied Ocean Research, Elsewhere, Ocean Engineering, member of Governing Council, CWPRS, Ministry of Water Resource, Government of India, Pune, to name a few. He has also been a reviewer of innumerable international and national journal papers, reviewer, research proposal under UK's EPSRC scheme, and a reviewer for research proposal Croatia government in the year 2013. He has also delivered keynotes, invited as talks at large number of workshops, seminars, conferences, examined PhD theses of candidates from Delft University, IITs, and IIScs. Having such a fashionable and dynamic, talented personality will definitely make the session very fruitful. Uh, with Sir's permission, may I request all the participants to switch on their video for a group photo.
Okay, thank you, ma'am. The photograph has been taken.
Okay.
Yes.
Sir, we welcome you and we are really fortunate that you agreed to give a session in our ATAL FDP. So I request you to start with your session, sir.
Okay. Okay. Good afternoon, everybody. It's a matter of great pleasure and honor for me to be associated with this course as one of the speakers. I thank the organizers for inviting me. Now, I am not very comfortable with this Zoom software because we normally use WebEx and others, so I hope there is no problem. But in case it arises, let us see, we can sort it out, I think. To start with, I will just start sharing my screen.
Yes, sir.
So,
Sir, it is visible.
is it visible?
Yes, sir. Properly visible.
Okay, very good. Thank you.
Yes, sir.
So, I will go ahead with the presentation now. As it has been mentioned, the topic of my presentation is coastal vulnerability against the climate change. Now, this presentation is based on the works of many of my MTech and PhD students and who have been working with me on this topic for about, I will say, 8-9 years or so. Now, I'm going to present the information that I have in 3 stages. First, assuming that there may be some participants or many participants who may not have got a good exposure to the basic information about climate change and climate modeling. So I will first spend some minutes on climate change and modeling basics. Then I will take you to the future sea level rise and shoreline erosion, which has a bearing on the coastal vulnerability. And then I will come to the vulnerability using multiple environmental criteria and social economic criteria. Now, I will, I will present theory to small extent, and I will give more importance to the practical applications so that this will be of more general interest to you. Now, as you know, as many of you may be aware of, climate change indicates changing climate variables over a long duration. Now, the climate variables are temperature of air, temperature of water, rainfall intensity, the wind speed, wind direction, humidity, air pressure, and so many other climate variables are there. And the word long duration is important. How long? It should be of the order of some many decades or even some centuries. If the duration is not of that magnitude, then it is not a climate scientifically, it is called weather. So weather indicates short-term changes in these variables, whereas climate indicates long-term changes in the variables. In other words, when we say climate, it is an average weather described by long-term spins statistically. Now, having seen the more scientific kind of concept of climate, now let us see what are the factors that affect the climate change. Now, theoretically, the factors are either external to climate or internal to the climate. External factors have examples like variation in solar radiation or astronomical variation, which are also called Milankovitch variations. Now, we all know right from our school days that when there are changes in solar radiation, when there are large number of sunspots, which means dark areas on sun, then Earth is subjected to colder weather and so on. Similarly, when it comes to astronomical variations, These are the changes in the parameters related to the Earth's orbit that is there around the Sun. So Earth's orbit parameters can change, and that in turn can change the climate. It also includes the configuration and tilt of Earth that changes. Now, when these factors change, they change the radiation flux received by the Earth from the Sun, and then the climate change can happen. But luckily, I will say, the external factors have got very large period, maybe several lakhs or even millions, and therefore they are not that much important in our lifetime. So the internal factors are more important. Now, internal factors again, which are responsible for the changing the climate, can be human-induced or they can be natural. Now, human-induced causes, also called anthropogenic causes, as we know. Coming to the natural causes, they include things like volcanic eruptions, deep ocean circulations. Now, these changes because of these, it can change the sea surface temperature and can thus change the entire climate. As against this, we have human-induced changes, which are because of the emission of what are called the greenhouse gases, methane, sulfur dioxide, carbon dioxide, and so on, and aerosols, suspended particles in this environment, air, and changes in the land use pattern and so on. There are so many reasons for that, human-induced changes. So now it's a more recent knowledge that human-induced factors are highly responsible for changes in the climate. Now, we all know that there is a UN body called IPCC, or Intergovernmental Panel on Climate Change. Now, this body doesn't conduct research on its own, but reviews the others' research and expresses its opinion and provides information to the policy makers of the world. So it reflects the consensus views of world scientists on climate change. Now, this IPCC has very categorically and unequivocally established existence of such global warming based on observed increases in average air temperature, average ocean temperature over the entire Earth. So the cause of climate change, one of the causes we can say, because of major cause level, is because of the global warming. Now, how global warming happens is a different thing, but the existence of global warming has been proved by them. Now, in the year 2007, IPCC had said that the global average temperature, which could be of the order of 14 degrees centigrade or so, increased by 0.74 degrees centigrade over the century, before last few years. The temperature rise in last 50 years has been mainly found to be because of greenhouse gas forcing. Now, sorry, these are actually the statistical information, and therefore people always attach some uncertainty to that. So they are not saying 100%, but there is a very strong possibility and near uncertainty that this could be because of greenhouse gas forcing. Now it is mentioned by them that the extremes in the environmental events, including storms, rainfall, etc., are most likely due to the rising temperature because of human intervention in the nature. Now, there is a latest release of IPCC's 6th assessment report, and you may have seen this news yesterday and today in media and newspaper, in which IPCC has said that based on the improved observational data sets and progress in scientific understanding of the climate system response, they are finding that the global warming may exceed by 1.5 degrees centigrade beyond the pre-industrial level in just next 20 years. So far it has been 1.5, but they are saying that in next 20 years it may be 1.5 degrees. Then they are saying that the coastal areas will see continued sea level rise throughout the 21st century, contributing to more frequent and severe coastal flooding in low-lying areas and coastal erosion. So this is they are, they are giving you the reason to understand more about the coastal sea level rise and associated effects. They are also saying that extreme sea level events that previously occurred once in 100 years could happen every year by the end of this century. But the end of this century is far away. We have to see about this. We have to be afraid about this thing that the global warming may exceed by 1.5 degrees centigrade beyond the pre-industrial level in just 20 years or so. Now, now in addition to that, India Meteorological Department analyzed more than 100 years of data up to 2009, and based on the collection of observation from 500 stations maintained by them, and they have shown that annual mean temperature of air over India rose by 0.56 degrees centigrade. It is slightly lower than the world, but again, that is because of less industrialization in this century. Then frequency, spatial coverage, as well as temporal coverage of extreme temperatures, heat waves, cold waves increased from 1990 to 2000 significantly. They have also said that over the last 2 decades, cyclonic intensity is found to be higher. Now, another IMD study has said that in particular, they are finding that the air temperature of Mumbai has increased by 1.6 degrees, higher than the Indian average during during the period of 100 years, around 100 years, 1901 to 2007. Then the profile of the temperature over the vertical has also changed. Now, how lower layers of air have become warmer and upper layers have become cooler. So there is a vertical temperature gradient. And as you know, when temperature changes, air pressure changes, wind changes, so many things change. So more intense and rapid air circulations can be expected according to the IMD state. Now, so having seen some general information about the increasing global warming and its Indian kind of parameters, now let us try to see how we can predict the climate or weather for that matter. Because we are all, scientists and engineers, and we want to know more about the scientific aspects of climate change and its applications. Now, for weather prediction, which could be at the interval of hourly interval or daily interval, we use numerical weather prediction models. Now, numerical weather prediction models conceptualize the flow of air circulation in atmosphere and into differential equations, and these differential equations are solved using numerical methods like finite difference, finite element, etc. Now, the basis of numerical weather prediction, so the basis of weather prediction is the numerical weather prediction models. As I mentioned, they represent a very complex array of very large set of simultaneous equations. They describe the movement of weather system based on the laws of conservation of mass, conservation of momentum, that of energy, water in all phases, then mass balance of water, then laws of thermodynamics. Then they are also based on the laws of incoming radiation from solar energy and outgoing heat radiation reflected by the earth and atmospheric gases, etc. Now, the input to these numerical weather prediction models is in the form of geography, topography, characteristics, soil cover, snow cover on the earth, sea surface temperature, etc. Now, as if this is not enough, they also need real-time observations through floating radar buoys, satellites, ships, land stations, etc. So all this information is needed if you want to make a good weather prediction. Apart from, and naturally, it requires very large set of computers. The model outputs from this NWP is in the form of hundreds of charts of air pressure, wind, humidity, rainfall, and many other parameters. Now, typically, such information is available over a 40 square kilometer grid size and at 70 layers, one over each other vertically, and also spread throughout the earth. Now, of course, there is a technique called nesting, which may give forecast in of one value within 4 kilometer by 4 kilometer grid sizes also. Now, typical forecasting interval there is 15 minutes, and forecasting horizon could be of the order of 10 days or so. Now, the numerical weather prediction models, which I have described just now, they focus on weather prediction, but for climate modeling, we need their extensions because when you say climate, the scale of the phenomenon changes. It is no more hourly or daily, but it is decade-wise or even century-wise. So what are called global climate models or general circulation models, they are based on same concepts, but they focus on climate prediction. Now, so the GCMs or GC, general circulation models or general climate model. These days, earlier they used to differentiate them to somewhat, but now they are taken as synonymous with each other. They focus on atmospheric circulation, oceanic circulation. They are suitable for projecting the climate change. They use a 3D, three-dimensional grid over the Earth as shown over here. Typical resolution of a general circulation model is of the order of 100 kilometers by 100 kilometers. And typical layers in the atmosphere could be 20, layers in the ocean could be 30. So you can see that it's a very exhaustive exercise. Now there are atmospheric general circulation models and oceanic general circulation models. We need always to couple them. Now this coupling is different than combining, because in coupling there is a two-way kind of exchange. When we combine, we just put one model behind the other. So in coupling of these models, it forms, when it is done, it forms an atmosphere ocean coupled general circulation model, which are naturally more accurate than a single AGCM or OGCM. Apart from that, there are also Earth system models, which include the response of Earth systems, such as land use, land change, etc. Now, GCMs or general circulation models, they are run for certain scenarios of global warming and social response. They are called representative concentration pathways. So it's a pathway leading ultimately to some values by 2100. Now, in the recent general circulation models, they are replaced, the RCPs are replaced by shared socio-economic pathways, SSPs, where there is some improvement in the formulation of pathways. Now, but whether it is RCP or SSP, these scenarios, they consider certain greenhouse gas emission levels, population growth, likely technological advances, global and regional economic response to the change in climate, and they account for emissions as per their 100-year warming potential. So this is a pathway basically leading to the condition that may happen by the end of 2100. Now, there are a large number of works done by different people based on an output from what is called CMIP-5 project. This CMIP-5 stands for Coupled Model Inter-Comparison Project, Phase 5. Now, here the experiments of many organizations of the world with respect to greenhouse gases, sea surface temperature, sea ice, ice sheets, over century as well as decadal scales are combined together, and then a combined output is presented to the user. There are a large number of output variables available under these 5 sets of GCMs. Some are annual averages, others are monthly averages, some are daily or even, and some are even 3-hourly. But for climate modeling, this short interval things do not are not that much useful. unnecessarily they repeat the results. Now, typically there are 4 RCPs involved. RCP 8.5 is shown by this curve, which is increase in set temperature versus years. It corresponds to figures like radiative forcing on the earth would be 8.5 watts per square meter. Carbon dioxide equivalent will be 1370 parts per million. Temperature increase anomaly will be 4.9 degrees centigrade, and the pathway as shown here will be always rising. This is the worst case scenario. This 8.5 is the worst case scenario. All these parameters are at for the year 2100. That's why it is a pathway relates to that. As you can see, this curve shows the RCP 4.5 temperature increase versus years. In RCP 4.5 warming scenario, at the end of 2100 year, the radiative forcing on the earth would be 4.5 watts per square meter. Carbon dioxide equivalent would be 650 ppm. Temperature rise will be 2.4 degrees centigrade, and pathway will be more stabilized. So this is a severe kind of pathway. This is stabilized pathway, and then there are two less severe, less stabilized pathways, lower pathways. But CME5 has been now, I will say, replaced by CMIP6 project output. Although CMIP5 is not abandoned, but some more efficient modeling output is available. So in CMIP6 project output, which is available from IPCC 6 assessment report, this project outcome attempts to address response of the Earth system to the forcing by means of taking care of model bias, that means difference with some actual observations, warming scenario uncertainties, internal variability among different models, etc. Now there are, so you can say it's a improved version of CMIP 5. But note one thing, that isolated studies have shown that it is not that CMIP 6 results will always be better than CMIP 5, because it depends on the region, it depends on the parameters that you are going to analyze, etc. So we can't just say that CMIP 6 project outcome will always give you better result than CMIP 5. But there are equal number of studies, or more slightly, which have shown that CMIP 6 outcome gives probably less uncertain results. So there are about 21 CMIP 6 endorsed model intercomparison projects, such as these two are examples over here. Now here in CMIP 6, RCPs are changing to SSPs, shared socioeconomic pathways, and they are forced by 1.9 to 8.5 watts per square meter forcing, accounting for all socioeconomic factors, including GDP, population growth, poverty levels, etc., which are not so strongly, covered in the RCPs. Now the problem with the use of general circulation in models is that the resolution is very low. That means the data are available at a very large spatial interval, like say 100 kilometers or 100 kilometers, and that one value. And therefore, downscaling is necessary to model the regional processes. For example, if I want to model the regional sea level rise, GCM directly will not give me accurate values because they are regionally average models. So we need to downscale these to what are called the regional climate models. There are two methods of downscaling basically, dynamic and statistical. Dynamic includes process knowledge, physics knowledge, whereas statistical, which are also more generally called data driven. Because apart from statistical tools, there are also artificial intelligence tools, which have been abundantly used for downscaling purpose. So dynamical downscaling uses process knowledge. Statistical downscaling uses data-driven knowledge. Now the whole process, as I mentioned, is extremely complex, and because there are use of different grid dimensions. There is a bias or in the output. It's a very high dimensionality or correlation among variables, and hence we use so many statistical tools like principal component analysis, standardization, regrading, etc. Now, further, there are alternative general circulation models, alternative warming scenarios, alternative downscaling method, statistical procedures, methods of assessment, and the whole issue is highly complex. And you must always specify the limitations of your work as a result. So this will complete my first part, namely the basic information about the changing climate and climate modeling targeted towards those participants who have so far not been exposed to these things in detail, in some details. Now I will go to the next part, namely sea level rise and shoreline change under the changing climate. Now this will ultimately lead me to the quantitative discussion on quantitative coastal vulnerability. Now the work that I'm going to present was actually done by one of my MTech students, who was a very bright student, Raghavendra Patil. Now, as I mentioned, since last about 9 years or so, there are so many PhD students whose name I cursorily mentioned here, who have done their dissertations, thesis with me under my supervision for their PhD work. Then there are these MTech students and more who have done their MTech works, or MTech dissertation under my supervision. And whatever I'm going to present is actually some extract from the works of the students. As you can see, now this list goes on like this. And why I'm projecting this is the reason is that in the short time, it is not possible to give you the complete overview of the all work that works done. But all this list of my publications is available on my webpage. And if somebody is interested, he can always contact me and I will give him a copy of all these publications there. Now, okay, so let us get started with this second chapter. Now, as I have mentioned, the Earth's temperature has been found to be continuously rising. This rise is reported to be because of human interventions in the mid-ocean process, as per IPCC. Now, the rise in temperature has a cascading effect on various coastal processes. For example, when the temperature rises, so many changes happen in coastal environment because when temperature changes, air pressure changes, therefore pressure gradient, that is wind changes. Because wind changes, wind generated waves change. Because wave magnitude and pattern changes, sediment process along the coastline changes. Because that happens, shoreline shifts happen because of the sediment imbalance. Then there is because all these things lead ultimately to the changes in coastal vulnerability. And that's what we are going to see at the end. Now, so there is when the temperature, so all these processes, they are temperature dependent. And so the change in temperature creates a cascading effect on all these processes. Now, in addition to these processes, changes also happen in global sea level and local sea level. Please know that global sea level is can be different than the local one, as we will see now because of various reasons which we will also see. Now, these changes in the sea level happen because of melting of the ice caps on mountains, melting of the ice sheets in the polar region, glaciers melting in the polar regions. And apart from this ice melting, snow melting, there is also a thermal expansion of surface seawater. And that also contributes to the change in the sea level. Now, earlier it was believed that thermal expansion of seawater because of global warming is causing rise in sea level. But now it is believed that more than that, the melting of the ice caps, ice sheets, glaciers, melting of snow in general, is a major factor compared to the thermal expansion. But nonetheless, you cannot just neglect thermal expansion. It is also important, may not be equally. Now, because we are all, I think, engineers, we would like to know, sorry, what are the crisp values of sea level rise rate? Now, earlier estimates of the sea level rise were like this. IPCC in 2013 had said that the past annual rate of globally average sea level rise was 1.7 millimeters per year from the year 1901 to 2010, and it increased to 3.2 millimeters per year in recent past from 1993 to 2010. This is based on observational data from satellites and whenever possible in situ observations. Then in future, they say that now different people apart from IPCC have made studies and they have given different values of the rate of sea level rise. But in general, on an average, it is agreed that in future, the global sea level rise may be 1 meter by 2100. Now, after seeing these figures like 1 millimeter, 3 millimeter, you may wonder whether this is really going to be important. But it will be because suppose the seabed slope is 1 vertical to 300 horizontal, and sea level rise is say 0.1 meters or 10 centimeters, then the shoreline submergence will be 30 meters. So there will be horizontal inundation of the order of 30 meters of the shoreline if 10 centimeter rise happens. Then there are so many studies in which the impact of sea level rise on coastal inundation in India has been prescribed. For example, the Daily Organization daily has said that if the sea level rises by 1 meter, then 9 coastal states of India will lose a land of about 5,763 square kilometers. Though this thing will get flooded, and 71 lakh people will be displaced. Then coastal states like Gujarat and West Bengal, they will suffer a highest land loss because of the topography there. Maharashtra, Tamil Nadu coastal region will see highest population displacement because of the high density of population in the coastal zone. Now, another study has shown that based on satellite measurements, the sea level rise, if it becomes 0.59 meters within next few decades, then 565 square kilometers of land of Andhra Pradesh coast will be lost. Now, such sea level rise of 0.59 meters plus tidal high water of totaling say 0.60 meters can cause submergence of 1,233 square kilometers of land there, and 13 lakhs people in the AP coast will be displaced. Now, another study has shown that if the sea level rise happens to 1 meter, then 13 square kilometer land of Kanyakumari district will be lost. So I'm giving some examples to show that don't get, myself that the rate of sea level rise is of the order of, say, 2, 3, 4 millimeters per year. It could still be considerable and dangerous. Now, so having some information about the magnitude, now let's see how we assess the past sea level rise. Now globally, it is assessed using numerical mass balance principle based on conservation of mass. In other words, it says that mass of water in all forms, whether ice, liquid, vapor, it remains same. So based on this concept, the mass balance numerical models are prescribed. Now, if some local instrumental data are available, then you have to carry out the statistical analysis. So you analyze the tide-based data, satellite-based data, etc. Now, how in the past people have assessed the sea level rise? They have used ice flow dynamic models, as I have mentioned, which are also called mass balance models. Then they accounting for transfer of water from glaciers to ocean. they have used RCMs, regional climate models. They have hindcast sea levels from a storm surge model. Then, so these are the process-based frequency modeling. For site-specific data analysis, they have used certain equations, developed certain equations which relate sea level rise with temperature. They also perform annual seasonal maxima fitting and trends of these values. Then they also model time series using either regression or machine learning methods. So these are the various ways by which the past investigators analyze the past data. Now, now this peninsular Indian coast, as you know, is of the order of 5,422 kilometers roughly. Now, India has about 1/3 of its population living within 50 kilometers from the shores. We have sandy beaches 43%, mud flats 36%, and you can imagine that these are all vulnerable beaches because when the sea level rises, the sand or mud will get loosened and erosion will happen, shoreline erosion will happen. Typically, Karnataka and Kerala coast has 75 to 80 such sandy beaches. So also Tamil Nadu, Odisha in different proportion, but equally formidable. Then it is seen that Indian Peninsula has already 23% of the land which is eroding, coastal land which is eroding. Now, as of 2019, it is said that the global average temperature rose by 1.06 degrees centigrade since 1880, as I have mentioned. Arctic ice has melted fast at the rate of 12.8% per 10 years. Ice sheets melted by 413 gigatons per year. You can imagine this much water is poured onto the ocean. And global sea level has risen by 3.3 millimeters per year. Now, according to another analysis by NASA based on satellite data, the sea ice cap shrank to 4.15 million square kilometers in 2019. And again, some people based on latest CMIP-6 models have shown that global warming is much faster and much higher than 1 degree centigrade than the one predicted by IPCC, or it could be even up to 6.5 to 7 degrees centigrade above the pre-industrial level of 2100. Now, as far as the sea level change is concerned, we should know that we are concerned with mean sea level rather than the short-term extreme sea level, because short-term extreme sea level will involve not only astronomical type but various meteorology and oceanographic components. So when we say, so actual mean sea level is a combination of all these, but we are concerned with long-term averages such as monthly average of sea levels, annual average of sea levels, etc. Now the local sea level rise can be lower than the global or higher than the global. This is because there are so many issues, so many features, characteristics, processes, and agents which create such imbalance, such change. So local sea level rise will depend on local sea basin shape, topography, local heating of water and its depth of water, local circulation of water, freshwater discharge, etc. from the nearby river. So please know that local sea level rise should not be used for civil engineering design, because and it should be used for civil engineering design and not the global. Global sea level rise should not be used for critical civil engineering design, but we must obtain local rise and use it as input in our designs. Now, having seen the sea level rise in general, what is the impact of the sea level rise? Because of sea level rise, as we can imagine, coastal land inundates. This could give rise to erosion and accretion because of sand erosion, and in case of accretion also because of change in circulation. Then waves will act more landwards. Then this sea level rise can reduce the protection of the bank coupled with the waves. Then plants and animals can get dislocated. There will be wetland loss, salinity ingress into the wells. Then there will be storm surge impact will be increased. There will be reduced safety for marine structures and port operation. So impact of sea level rise over say 3 decades, 2 decades, or 4 decades or more will involve all these kind of issues. Now, there are many past works on sea level rise in India based on the past data. And they show a very highly varying trend, highly varying nature of values. But these values are generally higher than the global values in general because of increased circulation patterns around India, as documented by some people. It is said that by one study by NIO people has informed that at the northeastern coast of India, the rise could be of the order of 2.25 millimeters per year. At the northern Bay of Bengal, it could be 3.2 mm per year. Eastern Bay of Bengal, it could be 5 mm per year. Then another study by IIT Kharagpur has shown that it could be 3 millimeters per year. Then there is a study sponsored by World Bank, not Asian Development Bank, which has shown that for the entire Indian coast, at minimum level, the sea level rise will vary from 1.92 to 3.44 millimeters per year. And at the maximum end, it could be 3.46 to 3.68 millimeters per year. But when you read all these values, you must remember one thing, that what is the basis of their specification. For example, these values are regionally average values, or the state-wise regional averages are present. Again, they are not representative of what is the exact sea level rise at Mumbai or Chennai or something, but they are in general of indicative nature. And because everything is uncertain, you always need some kind of certain level of confirmation from parallel studies. That's why these studies are important. Now, University of Colorado and United States National Center for Atmospheric Research, they have shown that the rise of sea level is high in Bay of Bengal, Arabian Sea. The reason being, there is a large pool in the Indian Ocean, which is called Indo-Pacific warm pool, which has got heated by 0.5 degrees centigrade in past 50 years. Because of that, two circulation patterns, which are Hadley and Walker circulations, they have intensified and they are driving stronger winds. Now, so this is also giving rise to increased sea level rise. Now, atmospheric people know more about circulation. Now, as you know, in India, we have always rising population. We are very ambitious about our economic growth. And there are plans to develop, big plans to develop coastal infrastructure, including ports, harbors, airports, power plant, sewage plants, roads, etc. in the coastal area. It is therefore necessary to study the impact of climate change at or near the port areas. Now, the study should be site-specific, and therefore case-wise evaluations are necessary for engineering designs. So the aim of the study that I am going to report now is was to study the climate change impact on two important components of the coastal ecosystem, namely sea level rise and shoreline change at beach areas close to 13 major ports. So we selected these beach areas near the 13 major ports, as we have shown here. 1, 2, 3 are almost similar overlap because it's a JNP and Mumbai port. Then this is 4, 5, 6, 7, 8, and 9 again Chennai and Madras. 10, 11, 12, and this 13, which is Port Bay. So we studied the beach areas which are close to these major ports. We predicted future sea level rise and obtained the coastal erosion using the Bruns rule in this work. In other works, which I'm going to describe, we have used numerical models, exhaustive numerical models. But for this work, we have purposely used Bruns rule because of some reasons, which I will elaborate later. The specialty of this work is that we have used the projected sea level rise and projected wave climate from climate models considering future global warming. Now, this is a very unique specialty of this work, unlike the past investigations. Then now it is clarified that we have not considered the impact on ports or port operations because the port and port operations will be mainly governed by wave-induced sediment flow rather than sea level rise. Therefore, we have focused only on nearby beach areas. The data needed for this work are like this. To obtain future sea level rise, we have taken the help of some database available from this CLIM Systems New Zealand web portal. It is based on what is called the pattern matching technique, in which global change of pattern is scaled to local sea level. Then future wave climate, we generated the wave data using general circulation models, wind. Now, as regards future sea level rise, the pattern matching technique is different than the conventional downscaling method because it is because it is claimed that the conventional downscaling sometimes change the signals, original signals obtained from past and future data. But this technique doesn't do that. Then future global patterns are taken from the ensemble of monthly sea levels of 28 general circulation models from CIMI 5 project. Now we have considered moderate global warming scenario pathway RCP 4.5, which means that the temperature rise would be 2.4 degrees centigrade by 2100. Now, I don't want to, I'm not going to the mathematical details of the downscaling, but know that the pattern matching technique has been found to be quite useful in peer-reviewed journals by some investigators. So our future sea level rise estimates are based on general circulation models and this Synclim database. Past sea level rise which we needed has been obtained from PSMSL website, which is Permanent Service for Mean Sea Level source, which gives annual as well as monthly tide data for around 2,000 tide gauge stations around the world from the year 1933 onwards. So all the world's tide gauge data collection authorities, they have some understanding with this PSMSL and they give their data to them, which is available for users. Tide gauges actually record, but this is important, tide gauges record sea levels related to a land benchmark, which is called relative sea level rise. But there is a vertical land movement also over a number of years because of tectonic activities, land subsidence, or groundwater extraction, etc., which can be known from GPS measurements or some models also. So in this work, we have obtained absolute sea levels corrected for the vertical land movement. Now, so this was the SLR rise. Now coming to the Broome's rule, this actually it is a very old rule proposed in 1954 by Per Broom. And I am very happy that Per Broom had visited CWPRS long back and also IIT Bombay. And we had good interaction with him. He has provided tremendous consultancy services to the port developments in India at that point of time in 70s, 60s, and so on. This Broome's rule is actually an empirical rule, but it is abundantly used with modification or even without modifications. The basic idea of the Broome's rule is like this. Suppose this is a vertical cross-section of the beach or beach profile. Let us say that this is the original cross-section of the beach profile. This is the sea level. So shoreline is this point, perpendicular to this point. Now, suppose we say that delta S is the rise in sea level. And so water level has gone up and it has eroded the sand here, loosened sand here. This sand eroded has got deposited like this. And now the changed profile is like this. Now, so the shoreline shift, now the new shoreline point is perpendicular to this point. So shift of shoreline is delta x. Delta S is the rise in sea level. B is the something like a limit or berm height for the rise. Then H star and W star represent the depth of closure or offshore boundary of the sand movement and horizontal distance to that. So this is the active profile as it is called, and these parameters only are involved in calculation of the shoreline shift in the Bloom's rule. Now these parameters, delta S is known separately, but these parameters have to be found out by using wave data. So we collect very long-term wave data, say of 30 years or so, and from that we work out all these quantities by these equations specified by different investigators. Now the characteristics, wave heights and periods for future period of time applicable at different coasts were extracted by us from the database of numerical wave simulations for future time period. Then these simulations were done with the help of Mike 21 shortwave software protocol of Danish Meteorology Institute. The numerical wave model was forced by a projected wind coming from well-established GCM, namely CM4, Regional General Circulation Model version 4. Now, there are a large number of studies which have supported the Brun's rule with the help of field observations, but it involves certain assumptions and approximations such as constant bed profile, uniform sand size, equilibrium of sand particles, no sand accretion, etc. And hence, investigators have also proposed modifications to it to take into account both seaward as well as landward sand supply, etc. Now, I'm not going into all these details because of want of time, because I see that I have got only 35 minutes or so. So this table gives the various parameters which we use. Coastal lengths typically varied from 2.77 kilometers at Port Blair to 26.60 at Goa. And this length was dependent upon availability of sandy beach near the port. Then this another parameter which we use for average beach width, significant wave height, significant wave period from the long-term data analysis, depth of closure, horizontal distance to depth of closure, average slope of the beach, berm height, etc. We took sediment size of 0.2 millimeter uniformly because of want of information at every place. Then these two are examples of trends in sea level rise at New Mangalore Port, this top, and Chennai lower. The linear trend equation is given along with the sea level rise at the end of the century, and the dotted line shows the linear trend fitted, while the solid curve shows the actual cumulative rise in sea level from 1995 to 2100. Now, so this is like that for every port, the sea level rise trend and values were obtained. Now, our result is for this part is like this, that sea level rise by 2100 at major ports of India, considering the general circulation model based projections, will be like this. Now, as you can see, the Kandla, JNPT, Mumbai, Mormugao, New Mangalore, Cochin, etc. They are west coast, and then Chennai, Ennore, Vizag, etc. along the east coast. So, in general, you will find that the east coast shows slightly lower sea level rise. So, east coast means a slightly smaller rise of sea level than the west. Now, again, there are past investigations which have confirmed this. This is because of the effect of larger bed slopes and higher water depths within the continental shelf, which in turn may cause the smaller thermal expansion of the surface water because of deeper thermal mixing along the east coast. Then at Chennai, there is a very small relatively sea level rise, and it may be because of local current circulation reducing any accumulation of water volume. Now, why this millimeters per year vary for different ports is that they depend on shape of the local basin, topography of the seabed, changes in circulation of currents, river discharge onto the sea, and so many other reasons which are site-specific. Then, so space variability in sea level rise has also been reported earlier, and I will not go into those details. Now then coming to the shoreline retreat based on that, Certain coastal lengths adjacent to each port were selected and the shoreline retreat was evaluated there. We avoided the exact port location because that will be governed more by longshore sediment transport byways rather than the sediment erosion from the sea level rise as envisaged in Green's rule. Now, the choice of the shore segment is governed by the presence of sandy beach and its length most closely located at the port area. This is an example of the beach which we selected near Kandla port, and this is the example of the beach which we selected near the Paradip port. Then this slide shows total sea level rise by 2050 versus the various ports. Each port is given a port number in a anti-clockwise manner. One stands for Kandla, 2 stands for Jawaharlal Nehru Port, etc., etc. 12 stands for Haldia and 13 for Port Blair. So again, here you can see that East Coast is subjected to smaller sea level rise relatively. Then this shows the shoreline retreat calculated by the Bruce rule using the projected data up to 2050. This y-axis is the shoreline retreat in centimeters, x-axis is the port number. And as you can see, the shoreline retreat horizontal in centimeter in this unit varies. For example, in 3 is Mumbai. In Mumbai, it will be 1200 centimeters and or 12 meters in next 30 years. In port there also it will be large, but in some locations it will be smaller. Now, actually, any direct relation of SLR, sea level rise, with the extent of shoreline retreat is difficult because they depend not only on SLR but also on the wave characteristics. But as per Bruce's rule, when the sea level rise is more, when the distance of depth of closure is more, the retreat will be more, and that's why we will see such differences. Now, this slide shows the what happens by year 2100. These are the serial numbers, these are the ports, this is the year 2100, this is the sea level rise up to that point of time, this is the shoreline retreat in meters, this is the area of inundation in square meter per kilometer, this is the percentage of beach inundated. And as you can see, because of the typical beach characteristics and sea level rise high, Jawaharlal Nehru Port is expected to have more beach inundation, whereas Paradip and others and Chennai may have small because of smaller sea level rise and associated beach characteristics as envisaged in the Bruce's rule. So the conclusion from our study is that the study should serve as an as an input in assessing the overall coastal vulnerability of the region near the major ports of India. This work is generic in nature and can be replicated elsewhere to carry out similar studies. Although the expected sea level rise would happen over a course of time, the results of this work should help in formulating adaptation and mitigation plans in a phased manner. This work highlights the fact that the regulatory and monitoring authority should seriously undertake, in a time-bound manner, appropriate coastal monitoring and restoration measures, such as inland rehabilitation of population, soft coastal defense measures, wetland protection, mangroves protection, and most importantly, they should strictly adhere to the CRZ coastal regulation zone guidelines. Because having served on the CRZ committees, I have found that there is a tendency to make exceptions, and sometimes these exceptions can have wide-reaching implications. Further, it is necessary to factor the risk assessment due to climate change in overall development plans of the region involved. Now, again, I will not go into some other issues, but we only wanted to caution that, like any other work, this work has also limitations because of the Bruce's rule mainly. Now, I will come to the last chapter, namely assessment of coastal erosion, siltation, and variability using projected data, framework, and case studies. Now, this study was done by Dr. Rajeshri under my supervision. One moment, please. Now, what is the need of this study? Traditionally, the determination of future sediment transport, coastal erosion, siltation, vulnerability, etc., is done with the help of historic wind wave data. But with the changing climate, we think it is more appropriate to do so using projected climate as per certain global warming scenario and sophisticated modeling methods, which were not so abundantly used in the past. So, hence, our objective was to determine future rates of sediment transport, coastal erosion or siltation, shoreline changes, coastal vulnerability, and finally coastal vulnerability using projected climate at selected stretches of coastline. Now, the framework that we proposed and followed is like this. We consider two time slices of 30 years in past and future, 30 years in past and 30 years in future. Then we obtain projected wind as per a regional climate model and a certain global warming scenario. Then using this as input, we ran in a numerical wave model and simulated the waves for past 30 years and future 30 years. Then, based on this wave modeling, we ran a coastal evolution model. Now, here we did not use the empirical Bruns rule, but we used a sophisticated numerical shoreline evolution model and determined sediment transport shoreline change. Then, with that help, we obtained future predictions of other physical and socio-economic variables and derived the quantitative coastal vulnerability index. And finally, we identify the changes into the future from the past. So this is the framework that we propose and follow. Our study area pertains to this Karnataka coast. Now we selected three regions. Region 1 in Uttar Kannada, North Karnataka. Region 2 here and region 3 here. Now this region 1 has specialty that it is around the Gangavali river estuary. Region 2 here is actually here it is a straight uninterrupted coast of Udupi, and region 3 here is a beach which in coastline surrounding the New Mangalore port. So three different types of discontinuities or continuities of the coast were studied. Now we all know that these coasts have diverse flora and fauna. There are sand spits, sand dunes, cliffs, rock outcrop, there are lagoons, creeks, river mouths. There are ancient temples and tourist attraction, and they are subjected to pressure from the population growth and development demand, and hence this study is important for that. Now, shoreline stability, as we know, is governed by the action of wind, waves, tides, currents, sediment transport, man-made interruptions, natural interruptions. To study the shoreline stability, we need to collect and analyze the data. How do we collect the data? We can have the data from hydrodynamic and morphological data from the beach profile, periodic beach profiles, aerial photography. We can have GPS-based surveys, also LiDAR-based surveys. Then we have we can get historical satellite imageries, sophisticated video camera images. We can use infrared camera imaging from unmanned aerial vehicles or drones. Then synthetic aperture radar, satellite-based sequential images combined with tidal models. Then we have marine navigation radar for imaging waterline and tidal record as done by various investigators in the past. Now, to analyze the collected data, it depends, of course, analysis technique depends on the data. The more common is in integrated numerical modeling of wave propagation, flow hydrodynamics, sediment transport, and shoreline change. So these are different numerical models put together. We have so many such choices here: Genesis, Unibase, LitPack, or DHI, Beach Plan, SBeach, XBeach, Web 3D, TediMax, Sand94, etc. Now, actually, they are based on the same basic aerodynamic equations, but in each numerical modeling, sub-processor model slightly differently, using slightly different equations, formulae, and alternative numerical methods are used. Now, some past work have shown that there is a relatively much smaller difference when you use more than one numerical models. Now, so data that we require for numerical modeling of shoreline changes is that of wind and waves, tides, past shorelines, near-shore bathymetry, cross-shore profiles, sediment properties. Now, again, in this work, for past evaluation, we have used reanalysis wind data, whereas for future, we have used general circulation models. And as you know, reanalysis data are derived from computational modeling coupled with observations. So they are supposed to be more accurate than general circulation models. But future observations are not available. So for future, we need to use GCMs only. Now, this information I already given to you. So we have used a set of regional climate models pertaining to coordinated regional downscaling experiment, or CORDEX, developed in the World Climate Research Program. Now, CORDEX experiment follows globally established methods of downscaling, and it uses validation based on large observations. So we have used the CORDEX data pertaining to Southeast Asia. They provide an ensemble of coordinated RCMs from 1950 to 2100 for most land regions of the globe, based on CME 5 and following RCP 4.5, 8.5, and 2.6. Now, coming to the assessment of coastal vulnerability, based on that, we need to remember that vulnerability means actually susceptibility to get damaged by external or internal causes. Coastal vulnerability can have two parts. It can be due to environmental factors or physical factors, or it can be due to social and economic factors. Examples of environmental factors are processes like wind, waves, tides, currents, sediment transport, shoreline ships. Whereas example of socio-economic factors are population rise, infrastructure demand, then road networks, tourist attractions, etc. So now quantitatively, coastal vulnerability is evaluated using Coastal Vulnerability Index. This is used to convert qualitative information into quantitative information. The concept behind CVI derivation is that we identify the causal variables or main decision variables. Then we assign ranks to each, like considering the range, low vulnerability to high vulnerability, etc. And we aggregate these ranks. Now, CVI is normally taken as an average of physical vulnerability index and social vulnerability index calculated separately because of the different nature of these two entities. Either PVI or CVI is a summation of WI into VI, I running from 1 to n, where n is total number of variables. W1, W2, etc. are the weight of the variable, and V1, V2, etc. are the variability score of each variable. Now, the weights are derived from analytical hierarchy process commonly, in which hierarchy of each decision variable, that means ranking of each decision variable, is assessed through a pairwise comparison among two variables so that relative importance can be brought into the picture that yields weights for each. Now, so again, the same framework we followed. We consider two time slices of past 30 years, future 30 years. We obtain projected wind daily maximum at these for 60 years as per regional RCM and warming scenario, Cordex 4.5. Using this data, we ran a numerical wave model and simulated waves. Then on that basis, we ran a coastal evolution model and determined sediment transport, shoreline change. Based on that, we obtained future projections of other physical and socio-economic variables and derive the coastal vulnerability index. And then we identify the changes in CVI from past to future. Now note that this is indeed a very exhaustive process, and it may take 1 year to complete this for a given location if you are trying to do it on your normal high-speed servers. If you have some supercomputing facility, you can do it on very high-speed servers. It may take less time, but the student took about 1 year or so to generate all this data and create all this information. Now, at this location of Uttar Karnataka or coastline of Karnataka, which we studied, mean spring tidal range was small, 1 meter to 1.5 meter. Longshore sediment transport was generally towards south, but had local reversal also in a given year. Now, this region is subjected to strong southwest monsoon and level V, northeast monsoon with a reversal of wind. Now, in this region, the sources of sediments are littoral drift, onshore transport, erosion of cliffs, erosion of foreshore, whereas the sediments can get dumped because of or removed because of sand removal by wind, mining activity, dredging activity, open channels, then estuaries and inlets. Now, we generate the wave data for past actually 35 years using the Mike 21 numerical model. And as we know in that model, the basic wave action balancing equation is solved using appropriate finite difference schemes to obtain mainly significant height, wave period, significant wave period, direction, etc. for different spatial intervals and space-wise intervals and temporal intervals, time-wise intervals. This is a typical example of the model domain that we consider along the Indian coastline. So that swells coming from Southern Ocean get accommodated here. Now, this wave simulation was done for past 35 years, future 35 years using wind data of Cordex. Actually, the wave data, now this wind data had resolution of 0.44 degrees by 0.44 degrees. But the wave data were obtained at much smaller interval because wave data were extracted at the onshore point, and from there, wave and hydrodynamic parameters were transferred along the reference cross shore at 10 meters grid spacing. So the data thus become applicable for the beach areas at small intervals because of this. Now this slide shows the validation of the wave model. The location is of Mangalore. Y-axis here is significant wave height. X-axis is the time in 3 years, 2001, 2003. This color shows observed significant wave height, this simulated significant wave height. This bottom figure shows the same result in scatter diagram. This is simulated significant wave height. This is observed simulated wave height, observed wave height, and this line shows the line of perfect match. As you can see, there is reasonably good match in between estimation and observation as quantified in correlation coefficient of 0.80. Now, our wave data analysis here showed that the annual mean and maximum significant wave height will increase here considerably in future. At this rate, the wave rows may intensify and slightly shift southward, as shown by this decadal wave rows this year. In future, higher waves may occur more frequently and lower waves less frequently, as seen by the comparison of the probability density function. The y-axis here is probability density function, x-axis is the significant wave height. This shows the old database values, this shows the projected database values in future. And as you can see, the higher wave heights will have higher probability of occurrence, higher frequency of occurrence. Now, in the DICPAC model, many of you may be aware that it determines the sediment transport and shoreline evolution by integrating hydrodynamic and sediment transport components. There is a hydrodynamic module which calculates the longshore current considering shallow water propagation, wave breaking, wave setup. There is a sediment transport module which takes input from hydrodynamics and calculates sediment transport using vertical diffusion and momentum balance equation. Then using this as input, there is a sediment mass balance equation which carries out the shoreline evolution, considering the effects of sediment sources, sinks, if there is a structure present. Now we did shoreline evolution model running for the years 2025 after 10 years. Now this particular time interval is selected considering the availability of satellite imageries for comparison and simulation purpose. Now, this shows the input in the form of 3 beach cross sections, wind roses. This slide, this figure here shows the graph of distance from the baseline, which is here into the sea of the shoreline, and this shows the along shore distance, and this is the simulated 2014 shoreline. Now this shows the tuning of the littoral drift model, or rather coastal and subsequently coastal evolution model. Littoral drift model was tuned as per the drift rates available from past investigation by adjusting the bed roughness, which was a tuning parameter there. This tuned littoral drift model provided the input to the coastal evolution or shoreline evolution models, and it was tuned with respect to the depth of closure. Now this y-axis here is distance from shoreline, and x-axis here is the along shore distance. Now these two lines pertain to year 2004, these two lines pertain to 2014, and you can see the observed shoreline as well as the simulated shorelines are fairly matching each other. Now this shows actually the information about the vulnerability parameters. This table, table 1, shows the source of data used in the present study. And as you can see, we consider seven physical parameters like geomorphology, shoreline change rate, mean significant wave height, mean tidal range, coastal slope, regional elevation, and sea level rise. Now this column shows the sources of various information involved. Now, as I have mentioned, shoreline change rate, mean significant wave height, etc., and sea level rise, they were calculated using the general circulation model for past and future by us. Then there were 4 social economic parameters like population, land use, land cover, road networks, tourism, and these are the various sources of data. Now we have used the past data as well as projected data of all these parameters based on socio-economic parameters. Projections are based on the available government reports, whereas these are based on the method which I have just described. Now, for these data and for each variable, this table shows the vulnerability ranking. The observed range of this variable was divided into 5 classes, varying from very low vulnerability to very high vulnerability. Very low vulnerability was given rank 1, very high was given 5. And this is how we calculate the ranks for later aggregation. Coming to social economic parameters also, the range of observation was divided into 5 classes, and then the rank was decided. But for qualitative variables like geomorphology, we applied the logic that if it is a rocky or cliffed coast, then it will have low vulnerability, very low vulnerability. So rank is 1. However, if geomorphology involves fines unconsolidated sediments, then it will have very high vulnerability. So give rank 5. So like that, we consider quantitative as well as qualitative ranking of various parameters. And this is the final result which I am going to show. It shows the change in coastal vulnerability index from past 30 years to future 3 decades. Now this figure is for coast around Gangavali River. This is for Udupi, which is a straight coast. And this figure is for New Mangalore Port, where the coastline is interrupted by port, the coastline is interrupted by estuary. So we estimated SVI and CVI, social vulnerability index, as well as physical vulnerability index, and finally CVI for every transact. So the shoreline was divided into different transacts, and for every transact, we evaluated these indexes for both past time period, future time period, and from their range, we did ranking considering the percentile values. So if the percentile value of a transact is less than 20, we called it very low vulnerability. If it is more than 80%, then we call it as a very high vulnerability. So from the range of this value, we did ranking considering this percentiles. Now each ranking, very low, low, moderate, high, very high, was differentiated by color as shown in this legend. So these different colors shows different levels of ranking. Then this line 1, curve 1 shows past CVI, and curve 2 shows projected or future CVI everywhere. Now, so every transact will have one CVI past and one CVI future, as can be differentiated from this legend color here. Now, what we conclude from this is that at this Gangavali site and for the chosen beach length, majority of the transacts will see a rise in of one level in their vulnerability. Their vulnerability will increase from very low to low at this site. Coming to the straight beach Udupi site, vulnerability may go up by 2 levels. So contrary to the expectation, a straight beach here has become more vulnerable because of a combination of 7 physical parameters and 4 socio-economic parameters in that way. So they will undergo increase in vulnerability from moderate to very high vulnerability for most of the transactions. Coming to the new Mangalore port, we are finding, if we compare this curve 1 with curve 2, that north of northern breakwater, this region, might see a rise of 1 to 2 levels in CVI, coastal vulnerability. That means from high to very high and moderate to very high. Whereas at south of southern breakwater, this, and at the middle transacts here, that area may see one level jump in vulnerability, that means from high to very high. So in general, we are saying that we are finding a rise in the coastal vulnerability when you consider projected climate data and projected socio-economic data. So in the end, we therefore find that in future, wind here will intensify, it will drive stronger waves. This in turn will raise sediment transport and accelerate erosion siltation. This will affect the future coastal vulnerability. Now, this study has emphasized the importance of using projected data and state-of-art modeling methods to predict future changes. It is actually generic in nature and can be easily replicated at any other location. So in the light of this study, we suggest that keep human interventions to minimum by balancing the developmental requirements with the increasing natural vulnerability. So we are not saying that stop every infrastructure development in the coast, but balance that potential infrastructure development with the increasing coastal vulnerability. We have to adopt more serious approach towards planning of coastal ecosystem in future and avoid relaxing of mandatory coastal zone regulation norms unless absolutely essential. Then we have to decentralize coastal population and infrastructure, adopt soft measures of coastal population such as coastal protection, such as beach nourishments, dune restorations, forestation, mangrove conservation, etc. Then, in case of changes around the ports, the port authorities may consider different shoreline management and dredging strategies in future than the past. So, actually, this is what I wanted to say. I think I was told that the lecture may go on for about 1.5 hours. That means from 3:30 to 5. It is already 5 o'clock. I mean, close to 5 o'clock. And subsequently we can have discussions. So I think with your permission, I will stop the sharing of the slide. So this is what I wanted to present, and if somebody wants to have any discussion, is most welcome with the permission of the organizers.
Thank you very much, sir, for the informatory session. So we have some questions in the chat box. So I request Bhagyashri Khartode ma'am to please read the questions so that participant will get the answers.
Good afternoon, all. Thank you, Shraddha ma'am. Sir, there are some questions by the participants. So, sir, first question is, how are coastal area affected by climate change?
Pardon? What is?
How?
Yes.
Hello, sir. Am I audible?
Yes, please speak. Just
First-
one moment. Because
Sir,
just one moment, please.
how coastal area affected by climate change?
Oh, sorry. So the question is how the coastal area is affected by climate. See, unfortunately, I'm in a lighter mood. I'm saying it is like asking how Sita was related to Ram after listening to the entire Ramayana, because my entire speech was devoted to that only. But just to, this is just in light of the vein. But I can just say the direct answer to this question is that climate change, I hope you are talking about climate change impact on coastal environment. Climate change happens because of, major reason being global warming. When the temperature rises, the air pressure changes. When the temperature changes, air pressure changes. When air pressure changes, the wind changes. Therefore, wind waves change. Therefore, wave-generated currents, then sediment transport changes. Then the shoreline changes happen, and coastal vulnerability increases. At the same time, because of glacier melting and thermal expansion of sea surface, the sea level rise also happens, and that also changes the coastal environment. So this is the probably direct answer to the query.
With the rise in sea level rise, is it essential to redesign the existing coastal structures, coastal protection work?
Okay, that has to be seen because I have not we have done a lot of studies, and in some of our studies we are finding that many times the many times the structures have a high margin of safety and can absorb the change induced by the climate sometimes, but not always. Because in one of our studies, we took a offshore platform, oil platform in the Bombay High region. Then we increased the wave height, significant wave height, considering the climate change. Considering the climate change at that location, we reanalyze the structures and we find that within the safety margin kept in the original design, the rise in significant wave height because of climate change can be absorbed. But again, this will be case specific. So if you are concerned about safety of existing structures, you have to check that safety with respect to the estimated changes.
Thank you, sir. Thank you, sir. I hope all the doubt participants are clear. Thank you so much, sir. For any further query, participants are requested to send an email to coordinator and same will be conveyed to sir. As per the convenience, he will revert to the mails. Is it okay, sir?
Excellent.
Okay, thank you so much, sir. Now I request to Dr. Deepa Joshi ma'am to propose vote of thanks.
Thank you, sir. On behalf of Department of Civil Engineering, Dr. D.Y. Patil Institute of Technology, Pimpri, and as coordinator of this ATAL FDP, I express my sincere thanks to Dr. Dev for his very knowledgeable session, and whatever the entire session he covered, he had divided it into 3 parts. One was about climate change and modeling, then future sea level rise and shore erosion, and in the third part he explained about multiple environment and socio-economic criteria. Sir, whatever complicated concepts you made it easy for us to understand, for the participants for their understanding. So thank you very much. And I request that whatever your association, I request for your association in future also with our department. Thanks a lot, sir. Thank you.
Thanks for giving me this opportunity to share our experience.
Thank you.
Okay, see you.
Yeah, yes, thank you.
Thank you so much, sir. Thank you, ma'am.
Yes.
The attendance link is shared in a chat box. All our participants are requested to fill the attendance and feedback.
Thank you so
Hello,
much, all
madam.
of you.
Hello,
Yes.
madam. Madam, I am
Yes.
audible.
Yes,
Yeah,
yes, sir, you are audible.
madam. Yesterday, actually, I presented all the session. I think it is recorded with you all. I am Dr. Sushobhan Sarkar from Kolkata GIS Group. I successfully given the responses, that is the feedback, both session 1 and session 2. And the
Okay.
afternoon session feedback submission, I had faced my network issue, so I could not submit the feedback. Yesterday, the last session feedback, like today, just now I am submitting. So yesterday I missed that thing, but I was present throughout the session.
Okay,
So what to do?
sir,
What is the?
We already communicated to you that you can write a mail to the coordinator. Your according to your consideration, it will be marked. Okay, so please make it sure that you can write the email to the coordinator.
Can you text the email of the coordinator in the chat box, please?
It's already in the FDP brochure, and which is already communicated to the respective participants.
Okay, thank you so much. Okay, thank you, thank you, sir.
Thank you, all of you. Tomorrow we'll start at sharp 10 a.m. Our first session for tomorrow's schedule is at 10 a.m. and we'll start at 10 a.m. sharp. So request to all of you, please join the session 5 minutes.